Hi guys, Dr. B here. So today your lecture is the addition of vectors. Our last lecture was the resolving or breaking up of a vector into its components. So now instead of using sine and cosine, we're actually going to use the tangent function, and also the Pythagorean theorem. So vectors can be added. The sum of two or more vectors is called the resultant vector. They can be in the same direction or in opposite directions. So you notice that when you add these two, you're still going in the same direction, east. However, these are two in opposite directions, so the resultant of a 4-meter going south and 2 meters going north is that you have 2 meters going south for your final vector. So vectors in two directions, how do we do that? So you don't have to necessarily use a protractor, but the idea is you try to draw out the first vector, and starting at the tip of it, you draw the second one, then you connect them. So like the idea would be the 5 kilometers east and the 3 kilometers south, and then you measure the connecting line or the resultant vector. And then you give the direction using the angle. So finding magnitude algebraically. So if your vectors form a right triangle, which these all will, you can use the Pythagorean theorem to find the magnitude of the resultant vector. So the c squared equals a squared plus b squared. But in terms of what we're doing, you can say it's the r for the resultant squared equals your velocity x component squared plus your velocity y component squared. Not velocity, I'm sorry, vector. Your vector components. And then to solve for the resultant, you would have to take the square root of all of that. So remember that you are squaring each of those things before you take the square root of it. So use a graphical representation to solve the following. Another hiker walks 2 kilometers south and 4 kilometers west. What is the sum of her distance? This should actually be, we'll say, displacement. So what's her displacement? So first things first, you draw your XY like a simple compass. So then north, south, east, west. So let's break these in different colors. 2 kilometers south. So you're going 2 kilometers south. This should be right on the line. My bad. Then 4 kilometers west. So what is the resultant vector? So what is her total displacement afterwards? So that will be from here to here. This is what we're trying to find, r. So this is in a right angle. So that's part one. So the rest you are going to write out your equation, r squared equals the x component squared plus the y component squared. So my r squared is your x component squared and then your y component squared. R squared, oops, that's ugly. R squared equals, well, I'll say that this. So from here, you can clearly see you need to take the square root of all of that after the fact. So the square root of 4 squared plus green, so 2 squared. So 4 squared plus 2 squared, that's 20. The square root of 20 is 4.47213. So you can see that it's clearly not just 4, but because of sig figs, you can say that it is approximately 4 kilometers. So this is why, sig figs is not the most, like sometimes it's not really the best thing to use, but in terms of keeping consistency, please follow our sig fig rules. Don't forget your units, and also don't forget to box in your answer, please. So finding the resultant vectors using the Pythagorean theorem. So a hiker walks 15 kilometers north. So, and 5 kilometers west. So this won't be to scale, but it will help you. So we are going 15 kilometers north. Let's make this 15 kilometers. It's fine. 15 kilometers north, and then we're going 5 kilometers west. Make that vector. Make this one go this way. 5 kilometers west. Then what is the resultant vector? So r squared equals my x component, which is the 5 kilometers. So that is squared plus north. So north is my y component. So that's like, kind of helps to know, like, your west and east will be your x component and north and south will be your y. So you're going to take the square root of both sides to get r itself. So this is 5 squared plus 15 squared. That should be, it's a 15, not minus. 15 squared equals, let's see, 5 squared plus 15 squared is 250. So the square root of 250 is 15.811, blah, blah, blah. So in terms of sig fig rules, again, not entirely accurate, as you can see. So 15 and 5, so only one of them has only 1. So then, oh, actually, yeah. So, so this one will be, well, we're not really taking square root. We're adding. So yeah, okay. So the nearest whole number. So should be, because there's no decimals after these, so the nearest whole number. So it will be 16 kilometers. We're just trying to find the resultant vector. We are not worried about direction yet. So a hiker, these are all hikers, so okay. A hiker walks 22 kilometers east and 37 kilometers south. So this definitely won't be to scale, but it's okay. So let's do, no, you probably can't really see that. Never mind. Do the same colors, it's fine. So east and south. So I'm going to use this for my, shoot, should have used it the other way around. So my 22 kilometers east, so that's my x component, so I'm going this way. 22 kilometers. Green, 37 kilometers south. So this would be pretty, not the best, but it's okay. So you're ending up, just so we know, just a reminder, we're ending up with with right triangles for these. So the next one is I'm trying to find the resultant, so I'm trying to find this one right here. R squared equals my x component squared plus my y component squared. 22 squared, golly, r equals 22 squared. What am I doing? 22 squared plus 37 squared, and remember we're taking the square root of all of that. So 22 squared plus 37 squared square root. So we will end up with approximately, well, we get at 43.046 blah blah blah, so 43 kilometers.